for 2025. Let's look at what we're going to look at. We'll look at the following content: climate and weather, and geomorphology. Let's many subtopics. The first one will be your mid-latitude cyclone, your tropical cyclone, subtropical, your traveling disturbances, moisture front, berg winds, coastal low, and then we're also going to look at microclimate. We'll look at your valley climates as well as your urban climates. But before we go to that, let's look at the synoptic weather map. Most of the climate questions will have something to do with a synoptic weather map. This is a normal synoptic weather map that you can expect, and then you should be able to identify what is the season represented on this synoptic weather map. Now let's look at what information you can use to deduce the information of whether it is a summer or winter synoptic weather map. Number one, you have to identify the features on the map. Number one, let's look at this. We have an L there in the interior. What does it show? It shows that the pressure is low, and which means the temperatures are high. The air is rising, and that is why we have that. And then what else do you see? You see a tropical cyclone. What else do you see? You see a coastal low. But what is the position of the coastal low? The coastal low is on the west side. Now, you must know when you do synoptic weather maps that different features will appear in different positions for different seasons. For an example, this is what we call a coastal low. What is a coastal low? This is a low pressure cell that exists along the coast. It originates or it develops on the west in summer and moves towards the east along the coast in winter. It moves towards the east. So when you see the coastal low being further west, you must know that the season is summer. And then when you see it further away towards the east, then you know the season is winter. So in this map here, this is summer, because number one, coastal low further further west, and then low pressure in the interior, indicating that the temperatures are high and the air is rising. And you can also see here, you have the station models that have got clouds. Most of the station models in the interior have clouds. So what does it indicate? It indicates that the conditions in the interior are unstable. What do we mean by unstable condition? It means the air is rising, and rising air will cool, and then cooling will followed by condensation, and condensation, precipitation. And during which season do we have most of our precipitation? In the interior, we have our precipitation in the interior during summer. So this is evidence that this is a summer synoptic weather map. You can also see what we have there: tropical cyclones, and tropical cyclones occur during warmer seasons, which will be your autumn and your summer. So it is clear that this is summer. So you can tell that. And then you can see as well that the mid-latitude cyclone is further south. We'll also look at the synoptic weather maps that examiners are using in recent times. They no longer use this standard synoptic weather map. Usually they will show a coastline of South Africa with certain features, but this is the exact synoptic weather map as we know. But recently, for examination purposes, examiners have started using diagrams that show the coastline and only showing the features of interest for the particular examination. So let's look further into the synoptic weather map. What do we see here? We see isobar. Every grade 12 learner should know that isobar is a line joining places with the same atmospheric pressure. And then what do we have there is coastal low, as we have explained it, what a coastal low is. And then what do we have there? This side, you have your South Atlantic high pressure cell. And then what you should know with the high pressure cell is the air is descending. That is why when we have Kalahari high pressure in the interior, we don't have condensation because the air is descending and it heats up. And then with a low pressure cell, the air will rise, and rising air will condense and form the clouds as you see in this synoptic weather map. And you must know the air circulation around the high pressure cell is anti-clockwise in southern hemisphere, but it is air circulation is clockwise for low pressure in the southern hemisphere, and the opposite will be correct when you go into the northern hemisphere. There's anticyclone will be clockwise and the cyclone will be anti-clockwise. Okay, what you see here, you see a cold front. Now, a common examination question that examiners will ask is identify the system. Identify the system. But if the question says identify the system, you cannot say the system is a cold front. The entire system is called a mid-latitude cyclone, and the cold front is the evidence. If the question says identify the system, you know the system is a mid-latitude cyclone. And what is the evidence that the system is a mid-latitude cyclone? It is the cold front. And then we're looking at the weather at Port Elizabeth, and then you look at the wind speed, you look at the cloud cover that is due to this mid-latitude cyclone that is approaching there. Now you have your South Indian high pressure cell, which is on the east. Then we're looking at the shapes of the isobars. When you're looking at the shape of the isobars here, the shape of the isobars are far from each other. What does it indicate? It indicates that the pressure gradient here is gentle and therefore the winds are weaker. But when you look at the shape of the isobars here, the isobars are closer. And this is on the east side. This is on the fourth quadrant of the tropical cyclone, where the wind speed are faster, where the winds are moving faster. So you can see now the shape of the isobars are going to communicate a message to you. They will tell you how the pressure gradient is, and the pressure gradient is going to influence the wind speed. So the wind speed will be higher at this point than they will be at this point, because here we have a gentle pressure gradient and here we have a steeper pressure gradient. What is pressure gradient, by the way? It is the difference between high pressure and low pressure, or high pressure minus low pressure is equals to pressure gradient. Then you have your tropical cyclone there, as I indicated, and the air circulation. The air circulation is clockwise. The air circulation is clockwise, or the air movement within the system. We call it the air movement within the system, or we call it the circulation. It is clockwise there. Now, let's look at the mid-latitude cyclone. So this is all grade 12 learners should know now about the mid-latitude cyclone. So these are different stages of development. Usually these stages of development, you'll get them when you're looking at short questions. Then what else do you see here? Let's look at the important stages here. We're looking at this stage is called mature stage. What is the difference between this stage? Now, let's compare the mature stage to occlusion stage. What do you see with mature stage? The warm sector. This is the warm sector. It is wider. The warm sector is wider in a mature stage. And when you look at the occlusion stage, the warm sector is narrower. Now, you have to find the reason. Why is the warm sector narrower in the occlusion stage? So now you have to go back to your definition. What is occlusion, or how does occlusion develop? Occlusion develops when the cold front catches up with warm front. Why does the cold front catch up with warm front? They are moving in the same direction. Both fronts are moving in the same direction, moving from west to east, because it is this is a mid-latitude cyclone. It moved from west to east, but you can see the pressure, you can see the steepness here, the steepness of the front here. The front here is steeper, but the front here is more gentle. Now, because of the steeper gradient, the cold front move faster. And because it moves faster, it will catch up with the warm front. Like at this point here, you can see that this cold front has caught up with this warm front. You can see now the difference between the front at this point and the front at this point. So you can see the cold front has already caught up with the warm front. And as the cold front catches up with the warm front, what do we get there? We get occlusion. We get occlusion. So why does the cold front catch up with the warm front? Number one, the cold front move faster. Why does it move faster? Because of the steeper gradient. And then it end up catching up there. It catching up with the warm front. And then why is the warm front moving slower? Because of the gentle gradient of the warm front. And that is why it's going to happen that the cold front catches up with the warm front. And then we're going to have this stage whereby we have the two fronts that are together. We have the two fronts that are together because the front that is faster managed to catch up with the warm front. And then what are we looking at here? Let's look at this diagram here. What do we have here? We have a mid-latitude cyclone in a development stage. We have another mid-latitude cyclone, which is now in the mature stage. We have another mid-latitude cyclone here, which is now in an occlusion stage. So you can say this one is a baby mid-latitude cyclone, this one is an adult mid-latitude cyclone, and this is an old mid-latitude cyclone. Now, if the question say, suppose we say this is a mid-latitude cyclone A, this one is B, and this one is C. The question is, among the three mid-latitude cyclones, which one is older? So like I said, this is a baby, this is an adult, and this is an old. So because they move from west to east, the one that is further east will be the older one. And you can even see with the characteristics, this one has already occluded. Occlusion has taken place here. And this one is still mature. Why do you say it is mature? Because it has a well-developed cold front and a well-developed warm front. And this one is still at the development stage. This one is still at the development stage. So this is now three mid-latitude cyclones together. What do we call the group of cyclones that occur together? We call it a family of cyclones. So we have 1, 2, 3 cyclones occurring together. What do you call it? A family of cyclones. Now, let's look at this diagram here. What do we have here? This is a diagram of a cross-section of a mid-latitude cyclone, a cross-section. So what is this now called? This one is called a plane view. This one is called a plane view. And you must know when you're drawing a plane view, you must indicate the symbols. But when you draw a cross-section, you do not indicate the symbols. So you have clouds here. With the cross-section, you will be able to see the clouds. You'll be able to see the precipitation. You can also see the wind direction. But when you're doing a plane view, you cannot see the clouds, you cannot see the precipitation, and you don't have to see the direction. So when you are drawing, if in an examination you are requested to draw a cross-section of a mid-latitude cyclone in a mature stage, this is a diagram that you should show. But remember, you must indicate, in geography we do exaggeration. So you must exaggerate the steepness of the gradients. It must be clear that this gradient is steeper than this gradient. I saw some people, when they do mid-latitude cyclone, they just draw a V which has got a same gradient in terms of the cold front and the warm front. Ensure that the cold front must indicate steeper gradient and the warm front must indicate a gentler gradient. And then because of the steeper gradient, there's going to be a rapid upliftment of air. And then because of rapid upliftment of air, now we're going to get cumulonimbus clouds, and we're going to have heavy rainfall, and we're going to have thunderstorms and plus lightning. So we're going to have thunderstorms and lightnings. So this is what you will get. And then also characteristics, you'll get also strong winds. But this is not only limited. This is not only limited to a mid-latitude cyclone. This is not only limited to a mid-latitude cyclone. There are three other weather phenomenon that have. There are three other phenomenon that are associated or that have cumulonimbus clouds. Number one that you have is it's a tropical cyclone, which is TC, and it is a line thunderstorm. Line thunderstorm. So there are three weather phenomenon that are associated with cumulonimbus clouds. So what you should know now, because it's three of them that have cumulonimbus clouds. When you talk about the impact, when you're talking about the impact on the natural environment, the impact will be the same. That is what I also emphasized in our previous lesson. In our previous lesson, I said we have three systems or three weather phenomena that has got cumulonimbus clouds. Number one is a mid-latitude cyclone, which we have here, the tropical cyclone and line thunderstorm. Now, what are the impacts? What are the impacts of these clouds? Will be the same. The impacts of cumulonimbus clouds, whether it is the cumulonimbus clouds with mid-latitude cyclone, cumulonimbus clouds with tropical cyclone, cumulonimbus clouds with line thunderstorm. So long as you have cumulonimbus clouds, the environmental impact will be the same. Let's look at the environment. So when you're writing paper one, you must remember, when you're talking environmental impact, the examiners usually will emphasize. The examiner will usually emphasize and say, what are the impact on the natural environment or physical environment? So when you speak of natural environment or physical environment, we are only referring to natural things. We are not referring to what people has made. So number one, let's look at the environmental impact of mid-latitude cyclone. Number one, it's going to result in soil erosion. Soil erosion. Because there is heavy rainfall, then there is going to be water that is washing the soil away. And now, when we have soil erosion, soil loses fertility. And then what else is going to happen? This can also destroy ecosystems. And then as it destroys ecosystems, it means it can destroy as well vegetation. This can also disrupt or destroy natural habitats. This can destroy natural habitats. Now, these are 1, 2, 3, 4, 5 factors. These are 5 factors or 5 impacts of mid-latitude cyclone on the natural environment. So, because mid-latitude cyclone is associated with cumulonimbus clouds, And also, tropical cyclone is associated with cumulonimbus clouds. And also, line thunderstorm is associated with cumulonimbus clouds. It doesn't matter what question or what phenomena will be assessed on Wednesday. If you get a question that says, explain the impact of mid-latitude cyclone on the natural environment. These are the impacts that you give because the clouds are cumulonimbus clouds. And we know what you must know about the cumulonimbus clouds is that cumulonimbus clouds are associated with rapid upliftment. They occur or they develop because of rapid upliftment. They are associated with heavy rainfall, and also you can also add hail there. You can also add hail and thunderstorms and lightning, and associated with strong winds. So all these weather conditions that we are looking at here, these weather conditions are the conditions that can be associated with the question says you must give the impacts of weather. You must give the impacts of either tropical cyclone, because I don't know what are you going to be assessed on. Is it going to be tropical cyclone, or is it going to be line thunderstorm, or is it going to be mid-latitude cyclone? So long as the question wants you to say the impacts on natural environment, you must know it is soil erosion. The soil will lose its fertility. It's going to destroy ecosystems. It will destroy vegetation. Whether you say vegetation or you say natural vegetation, it is still the same thing. It is vegetation is natural. And you can say it also destroy natural habitats. So for any natural impacts, be it of any of these, must be careful. So don't go and study impacts on the impacts of the mid-latitude cyclones. Then you go and study impacts of tropical cyclones. Then you study impacts of line thunderstorm. They are the same. Once you have studied impacts on the natural environment, you are done. But sometimes the examiner may say the impact on the coastal environment. They can say the impact on the coastal environment. So when they say the impact on the natural and not on the natural, on the coastal environment, then you can give all other facts. You can give all other environment. You can look at man-made environment that is going to destroy the harbor, because the question is open. It says coastal environment. It does not say natural environment. So which means now you can also bring about the destruction of ports, of harbors, of the ports, and all other things, infrastructure, and all other things that are not natural. So you must be careful, read what the question wants. If the question wants physical environment, you must give physical environment. If the question is open and it says to the coastal environment, then you give coastal environment. But you must also be careful. Is the question saying impacts, or is it saying negative impacts? If the question is saying negative impacts, you must know you must only give negative impacts. But if the question just say impacts, you can be positive, it can be negative. But if the question is saying negative, it can only be negative. So which means you cannot say tropical cyclones are going to bring water for irrigation. You cannot say mid-latitude cyclones will make sure the dams are full. You cannot say line thunderstorm make sure that the water is full. There is nitrogen fixation. That is positive impacts. Be careful what the question wants and only respond to what is being assessed. Now let's quickly look at the mid-latitude cyclone here, which is circulating clockwise. Now, what are you looking at here? You're looking at the different station models. You're looking at different station models. Let's say this is station model A, this is B, this is C. So when you look at this one, Where is rainfall more likely to take place among the three of them? Rainfall is more likely to take place at A because it is also indicated there as precipitation there. Rainfall that is going to take place there. The type of precipitation is shown there. So why do we have rain here, not in others? Because number one, there is overcast condition. There is overcast condition, and then the difference between air temperature and dew point temperature is very small. So the air must drop by 2 degrees Celsius before condensation. So it's only, the temperatures will drop from 16 to 15 and from 15 to 14, then condensation takes place, which means now the water vapor will change to water droplets, and the water droplets are heavy to hang in the atmosphere. So they come down as a precipitation. And you know what is a precipitation? Is any form of moisture that's falling from the atmosphere. Okay, now what you're looking at here, you're looking at the circulation of a mid-latitude cyclone. So if you are to draw a line, remember this line here is indicating the wind direction, and these lines here are indicating wind speed. So what is the wind speed here? It is 10, 20, 30, 40. So here we have 40 knots. What is the wind speed here? Is 10 and 5, which is 15 knots. And here it is 5, 10, 15. I mean, it is 10, 20, 30. So we have 30 knots here. But what is important here? What is this indicating us? This is indicating us the clockwise circulation of air, because the air is always blowing into the circle, meaning that the air at this point is coming from here, is going into the circle, and is rotating like that, coming from there, going into the circle, going like that. So this air here is coming from this side. So this shows a clockwise circulation of air. This indicates the clockwise circulation of air. So with this diagram, then you can see that the mid-latitude cyclone rotates clockwise. So remember, the air is coming into the circle. The air is blowing into the circle. The air is blowing into the circle. So this lines of wind direction are indicating the change in wind direction. It was coming from this point, it came from this point, it came from this point. So this shows the clockwise circulation of air. And then what do we call that process? We call this process baking. We call this process baking. When the winds were coming from this direction here, then the winds came from this direction there, then the winds came from that direction there. So the process that you see happening here, it is called baking. Is the change in wind direction in the southern hemisphere. So this is what we call baking here. So let's look at the characteristics now. We have your warm front here. What happens when the warm front passes? The temperatures are going to rise because it's called warm front, and then air pressure will drop because now the air is warm, and then which means it does not subside. The wind will change from northeast to northwest, and the cloud cover will decrease and rainfall will stop. Now, what happens when the cold front comes? Temperature will drop. When temperature drop, air pressure is going to increase. What makes the air pressure increase when the temperature drops is because cold air is heavy. And when it's heavy and denser, because it is heavier and denser, what is it going to do? It is going to subside. And when it subsides, it creates higher pressure. And now you can see the wind changes in direction. That is because of that clockwise circulation. And the cloud cover is going to increase because rising air will condense. Rising air condenses and increases cloud cover, and we can experience precipitation. We can experience heavy rainfall. So this diagram, I simply want to indicate to you the circulation of air. It wants to show the circulation of air, the clockwise circulation of air. Air coming from this direction, following like that. So that is, it is merely to indicate the air circulation in the or around the low pressure cell or around the cyclone. Now, let's quickly go to this synoptic weather map. So this is what the examiners are currently using as synoptic weather map. They no longer use those synoptic weather map that are very full of diagrams, but it does not mean they will not use those synoptic weather map. But the current trend with examiners is that they draw their own coastline of South Africa and simply put the features that they want to assess you on. So what we have there, we have a synoptic weather map. The question is, the synoptic weather map illustrates typical conditions. What is it, winter or is it summer? Now you have to interpret this. What do you see here? You see L in the center, which means now the temperatures are high. So this will be typical summer condition. And you can see now this L here, you can see the isobars here. They are not just round, they are a little bit oval. So when you see an elongation, this is elongation. So what do you call this? We're going to call it a trough. What is a trough? Is an elongated low pressure cell. But what is the name of the trough that we experience in the interior of South Africa, especially during summer? It is called line thunderstorm. Not line thunderstorm, it is called moisture front, rather. This is a moisture front. This is a trough. It is a elongated low pressure cell. It is called a trough. Now let's go to the question 1.1.2. It says line AA, which means line AA, this line over here, this line over here. Line AA represents a ridge or a trough. So this is a high pressure cell. This is a high pressure cell, and this high pressure cell is elongated. So what does it mean? This is a ridge. This is a ridge. What is a ridge? Is an elongated high pressure cell. And what is a trough? Is an elongated low pressure cell. So we have our answer there. The air pressure reading of isobar B is, now you have to look at isobar B. Here is our isobar B. What is the air pressure at B? Now look at the trend. It shows here that the pressure is increasing. The pressure is increasing when you go towards that H. The pressure is increasing. But now let's look at what is the isobaric interval. What is the difference between one isobar and another, or from one isobar to another? What is the difference in isobars from one isobar to another? So our isobaric interval here is 4. So here we have 1000, here we have 1004. So which means the next one will be 1008. This one will be 1008, and this one will be 1012, because we are looking at the isobaric interval of 4 millibars or 4 hectopascals. So now the question is the air pressure reading of isobar B. Here is the isobar B. So the pressure is increasing northwards, so, or towards the H there. So as you do that calculation, you say this one is 1000, this one is 1004, which means this one will be 1008. Then you say 1008, when you add 4 into it, is going to be 1012. So which means now the correct answer there will be 1012, which is a Y. Then the air pressure gradient is steeper around the weather station at D or at E. Let's look at the weather station at D. Look at the isobars there. Look at the isobars. Remember, it becomes steeper when the isobars are closer to each other, and it becomes gentle when the isobars are far from each other. Now let's look at E. This is our weather station at E. Now look at the not the difference. Let's look at the distance. Let's look at the distance between the isobars here. Let's look at the distance between the isobars here. The distance between the isobars here are far from each other, but the distance between isobars here is that they are close to each other. Now let's answer this question. The air pressure gradient is steeper around the weather station at D. It will be at D because the isobars are closer, but here the air pressure, it will be gentle because the isobars are far from each other, which means the winds that will blow here will be weaker than the winds that will blow here. Let's see if it's true. Now, yes, look at the winds here. So the wind speed here is 10 knots. But what is the wind speed here? This is 10, 20, and 25. The wind speed here is 25 knots. The wind speed is 25 knots. The wind speed here is 10 knots. And what is influencing that is the distance between isobars. The distance between isobars here, making it a gentle pressure gradient here, making it a steeper pressure gradient. And what is the evidence that we see again? You can see the wind speed here. The wind speed here, it is 25 knots. It is 25 knots, and the wind speed here is only 10 knots. And remember, if you have this isobar, this wind speed here, it's indicating 5 knots because it is a half knot, but it is not at the beginning. It is not at the beginning. But if you see a knot like this one, is also 5, also indicating a gentle pressure gradient with the weaker wind speed. Weaker wind speed and gentle pressure gradient. Okay, now let's go to the next one. The northeasterly wind at Durban is influenced by the circulation of air. Now let's look at Durban. There is our Durban there. I'm sorry, I put a lot of writing on our Durban here. So it is influenced by anti-clockwise or clockwise. So what do we have here? We said the season is summer. The season is summer. And now we have the high pressure cell here, which is called South Indian. So this South Indian high pressure is going to blow in the warm, moist air here, and this one is going to blow the cold, dry air. That is why we have this trough over here. That's why we have this trough over here. So what do we have? This is a trough, and what do you call this trough? We call it a line thunderstorm. We call it a moisture front, rather. Why do I keep on calling it line thunderstorm? It's a moisture front where line thunderstorm is going to develop. So the question is, the northeasterly wind at Durban is influenced by the circulation, anti-clockwise or clockwise. Now we're saying it is because of the anti-clockwise. The influence is mainly because of what? Of this South Indian high pressure cell. And this side, it is South Atlantic high pressure cell. So the warm, moist air going there and the cold, dry air going there. Warm, moist is lighter, is going to be forced to rise, or this cold, dry air is going to undercut. The cold, dry air from the South Atlantic is going to undercut the warm, moist air or the northeasterly winds from the South Indian high pressure. And then on the side, we are going to have condensation, rapid condensation, or we're going to have rapid rising, and we're going to have high level of condensation that is going to result in a line thunderstorm on the east side of this a moisture front. We're going to have line thunderstorm because the air on the east is lighter and therefore is going to be forced to rise higher and result in cumulonimbus clouds and heavy rainfall. And heavy rainfall that is going to have the same impacts. It's going to have the same impact as tropical cyclone and mid-latitude cyclone. Okay, now let's continue here. The unstable weather conditions at weather station C. This is weather station C. Why do we say the weather conditions are unstable? The weather station here, the weather conditions are unstable because you can see clouds. You can see clouds here. The clouds is an indication of unstable weather conditions. If the weather conditions are stable, the air is going to settle on the ground. But if the weather conditions are unstable, the air is going to rise. And rising air will cool, and after cooling, it's going to condense and form clouds. And after clouds, precipitation. Now, the question is, the unstable weather condition at weather station C are due to the development of a what front? Is it a cold front or is the moisture front? So it is due to a moisture front. It is due a moisture front. And then they say here, which weather station illustrates the following weather changes at F? Weather stations, changes of weather stations at F. Here at F, is it the wind direction that is going to change in the southwest, and these are the changes. So you have to say, where are we going to have the wind direction that is going to change to southwest, and the air temperature that's going to decrease by 6. So now, we're going to separate to say, at this point, for condensation to take place, the temperature is going to drop from 24, then it goes to 23, then it goes to 22, it's going to go to 22, then it's going to 21 and 20, then 19 and 18. So this is the station model that show these characteristics, where the difference there between dew point temperature, which is at the bottom. This temperature is called dew point temperature, or is called minimum temperature, and this one is called maximum temperature or air temperature. So this is where you have the difference. So which means the correct answer there will be number Z. Now let's look at the question now. Says, name the winds that are responsible for the westerly movement of the mid-latitude cyclone. Which winds are responsible for the westerly, or for the easterly, not westerly, for the easterly movement of the mid-latitude cyclone? So the correct answer there will be the tropical, not the tropical westerlies, but with the tropical westerlies, you can just say westerlies and you are correct, because we've got only one set of westerlies in the atmosphere. But with the easterlies, you have to specify whether it's polar easterlies or tropical easterlies. And the other quite simple question, they say identify front A. What is front A? This is a cold front, and which one of front A or front B is moving faster? We've already said it is front A, which is moving faster. Why is it moving faster? Because of the steeper gradient. Because of the steeper gradient, and it's going to end up catching up, and therefore resulting in the stage called occlusion stage. And they say, give evidence from the sketch that the mid-latitude is found in the southern hemisphere. What is the evidence that it is found in the southern hemisphere? What is the evidence that it is found in the southern hemisphere? It is because the wind speed behind the cold front is faster. It is faster. The wind speed behind the warm front is slower, and then ahead of the front, the warm less dense is lighter. Ahead of the warm front, the air is colder and denser. Warm front uses energy to move forward and rise. The pressure gradient associated with the cold front is steeper. So those are the questions that you expected to give there. I'm looking at the wrong questions here. I'm answering the wrong question. Give reasons for your answer. Here was, why is it moving faster? So those are the answers that you could give. So here, these are the answers to 1.3.4, this one. And now let's move to 1.3.5. Give evidence from the sketch that the mid-latitude cyclone is found in the southern hemisphere. There is clockwise circulation. You can see air coming from that direction, air coming from that direction, air coming from that direction. So when you join all these directions, it's showing that there is clockwise circulation. Position of the low pressure is south of the system. So the position of the low pressure is south of the system. Warm sector or cold sector is in the north. This is the warm sector, which is in the north. And baking of the wind occurs. The baking is this change of wind direction. And the apex is to the south. The apex is to the south. So you can see the apex being at the south. The apex would have been in the north if it was in the northern hemisphere. Now 1.3.6, what is the question saying there? 1.3.6, which one of the cross sections Y or Z represent the cold front occlusion at sea? Which one represent the cold front occlusion at sea? So at sea we have cold front occlusion. Now which of the two diagrams show cold front occlusion? The correct one will be this one at Z. Why this one at Z? because the cold front is the one that is touching the surface. The cold front is the one that is touching the surface. This one is the warm front occlusion because the warm front is touching the surface. So when you draw this cross section, you must also indicate direction. You must also indicate direction of the system. You must indicate direction of the system. And if the examiner asks you to draw a cross section, you must label your cross section. You must say cross section of a mid-latitude cyclone in a mature stage, or cross section of a cross section of a cold front occlusion, a cross section of a warm front occlusion. You must always give labels to your diagrams. You must always give labels to your diagrams. Okay, now we have given give evidence that C is a cold front occlusion. Why do we say C is a cold front occlusion? Why do we say C is a cold front occlusion? Because we can see the cold front is touching the surface. Cold front is touching the surface. That's why we're saying that. Explain how the cold front occlusion will develop. How cold front occlusion develops. So you must say now the cold front has a steeper pressure gradient. Because of a steeper pressure gradient, the cold front is going to move faster, and because it moves faster, is going to catch up with warm front, and then what is going to do is now going to undercut. It's going to go beneath the warm front, and what it's going to do is going to uplift the warm front completely from the surface. So that is how it's going to happen. It is steeper. Because of steeper gradient, move faster, and then when it move faster, it undercuts the warm front, and then after undercutting it, it completely removes it from the ground. Now, let's move quickly to our tropical cyclones now. When looking at tropical cyclones, I hope we understand, I hope you will be able to get all the marks that you need to get in mid-latitude cyclones. Mid-latitude cyclones are such an easy topic for you to get all your marks there. Let's quickly go to our tropical cyclone. So what do we have there in tropical cyclone? We have the movement of tropical cyclone. It moves from there. It occurs on the tropics between 5 degrees and 30 degrees. It does not occur at 0 degrees because the correlative force is very weak at 0 degrees. So it occurs from 5 degrees because it requires correlative force. So those are the requirements of tropical cyclones to develop. Number one, it requires a strong coriolis force. We cannot say it requires Coriolis force. It requires a strong Coriolis force. It requires the surface temperatures of 27 degrees, sea surface temperatures of 27 degrees and above. And it also requires a lot of evaporation. It requires a lot of evaporation. And now we're looking at the condition of the eye of a tropical cyclone. There is no wind in the eye of the tropical cyclone. There is no rain in the eye of a tropical cyclone. And there is also no clouds. So obviously, without clouds, you will not get rain. So this is the movement of tropical cyclone. It moves from west to east. And then when tropical cyclone moves over the land, they dissipate over the land. Why do tropical cyclones dissipate over the land? Why do tropical cyclones dissipate over the land? Because there is friction over the land. Friction is high, no moisture. And then the cold air enters into the system. The cold air will enter the system. So there is less water masses as well. So that is why tropical cyclone will die over the ocean. So you'll see tropical cyclone moving over Madagascar with certain amount of speed. But when it moves here, the speed might increase because now it is moving over the ocean. So why is the tropical speed reducing over the land? Mainly it is it is because of there is no moisture. It's because there is high friction over the land. So let's look at tropical cyclone. Explain why satellite images are effective for tracking. So this is tropical cyclone management. Why is it important to use satellites? Because data is received in real time. Satellites are giving you a live feed of whatever process is taking place, and the data can be monitored every hour. It can determine the intensity of storm, whether it is category 1, category 2, category 3, and we know we are going to prepare differently for different categories of storms. And you can also use the satellite images to predict the path so that people can be given a timeous warning so that which areas they can avoid and which areas they can go to for evacuation. And it is also important because large inaccessible areas can be monitored because some of the areas you cannot access them with vehicles or with road or rail transportation. So, but the satellites are higher in the atmosphere, so they can be used to monitor that because they are not on the surface. The satellite images are not on the surface; they are in the space. So it's going to be easy for you to monitor whatever is happening on Earth when you are looking at it from space. Now, here are some of the examination questions that you can expect to get. Okay, let's look at a few activities on a tropical cyclone. Here is the first question. Give the date on which tropical cyclone Batsirai reached the mature stage. So, when you answer these kind of questions, use you simply use a diagram that you have in front of you and you interpret it. And they say, according to the infographic, tropical cyclone Batsirai moved westwards across the South Indian Ocean. Give one reason for this movement. So it moved. Now you have to decide why tropical cyclones moved westwards. So you have to use that question. I mean, you have to use your information on tropical cyclones that they move from east to west because they are driven by tropical easterlies. Suggest two reasons for the large decrease in wind speed between 20 and 25. Now, where is 20 and 25? There is 20, there is 20, and there is 25, and the cyclone is moving in this direction. Now, give a reason why did the wind speed change here. You can see now it was moving over the land. So there was high friction over the land. The system was moving over the land and there was a lot of trees over the land. There was a lot of buildings over the land. So you can look at number of reasons that would make the tropical cyclone to slow down over the land. How could storm surge negatively impact the physical environment? Physical environment. Now, we have already spoken about the impact on the physical environment or natural environment. So we are not going to go back and look at that. We said it causes soil erosion. We said it destroy natural vegetation. So the very same question that you give when you're talking about tropical cyclone, you give the same, the very same answers that you give for mid-latitude cyclone, you are also going to give the very same answers to tropical cyclone because the clouds are the same there. They are cumulonimbus clouds. So the very same answers that we gave there, we are going to also give them. Now the question is, explain the importance of monitoring tropical cyclone. Why is it important to monitor tropical cyclone? Because the area is prone to tropical cyclone, to observe the path and know the strength, to observe the development of a tropical cyclone so that enables advanced predictions, enable correction of data, effective providing of warning system to reduce level of impact of the system, to prepare and limit possible damages, to have enough time to evacuate, to plan, number of reasons. So this is not, it's not limited to this. To avoid losses of life or loss of life so that people can act on time. This is an application question. This is an application question. Everybody should be able to give one answer. I mean, two answers here. Everybody should be able to give why it is important to monitor tropical cyclone. Why is it important to monitor tropical cyclone? So this has a lot of answers. It has a lot of answers. Out of 100,000 learners, we expect to find 100,000 different answers there. So it does not have to be same to any other answer. Or you can see here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it must link to any of this. It must link to any of this, but you find your way of answering these questions. You use your own ways to answer this question. Don't summarize, don't memorize these answers. Don't memorize these answers on importance. Use your own ways to show understanding. Now let's look at the subtropical anticyclone. What do we have? We have 3 anticyclones. We have Kalahari, which is in the interior, South Atlantic, which is on the east, on the west, and South Indian on the west. So the anticyclones, what do they do? This one is blowing on a cold ocean, this one on the warm ocean. So the 2 air masses blow towards the interior, and we have already spoken about the system that will develop here. The 2 air masses form. And the Kalahari is dominant in the interior during winter. And during summer, it rises higher in the atmosphere. So these are 2 diagrams that indicate different seasons. So look at the inversion layer here. The inversion layer is below the escarpment. Why is the inversion layer below the escarpment? Because the Kalahari high pressure is dominating the interior. So this diagram and this diagram are related. So this is a typical winter condition. And you can see now the high pressure cell is further north. The high pressure cell is further north, and therefore it's going to allow the passage of the mid-latitude cyclones to pass into the interior. That is why we say mid-latitude cyclones affect the weather of South Africa during winter. Why during winter? Because the high pressure cells have moved or have migrated further north following the ITCZ. They have migrated further north following the ITCZ that has moved to the northern hemisphere. And therefore, they have now opened the gate for mid-latitude cyclones to come through. That is why the examination question will be, during which season do mid-latitude cyclones affect the weather of South Africa? And you say during winter, because the high pressure cells have moved northwards following the ITCZ, because they are attached to the ITCZ, and therefore they allow the passage for the mid-latitude cyclones to pass through. Now, this is summer. Why do we say it's summer? There is L. What does L represent? Low pressure. Why do we have low pressure? Because the temperatures are high and the air is rising. And therefore, what do we see now? During summer, we don't receive a lot of mid-latitude cyclones because this mid-latitude cyclone is going to hit, is going to be deflected here and move further south. So because what? The high pressure cells have moved southwards. The high pressure cells have moved southwards. Why did the high pressure cells move southwards? Because they are following the migration of the ITCZ. When the ITCZ moves southwards, the high pressure cells also move southwards. So what will be the impact of high pressure cells moving southwards? They are going to block the mid-latitude cyclones and stop the mid-latitude cyclones from flowing into the interior. But this is what we call South Indian high pressure. It is also known as the blocking high. It is also known as the blocking high because it reaches ahead of the mid-latitude cyclone and stop mid-latitude cyclone from moving further into the interior. So we have South Atlantic and South Indian. This South Atlantic is also referred to as the blocking high. Now, what do we have here? We have we have the cross section. We have the cross section, so we can see the warm moist air is able to reach the interior. So this will be the moist air that is reaching the interior as your northeast winds there, and then we have cold dry air as your southwest winds there. Then they are going to have air moisture front there. Then you're going to have your line thunderstorm there. So that is what we're going to experience during summer. This is what we experience during summer. We experience precipitation because the Kalahari high pressure has moved higher in the atmosphere. When it moves higher in the atmosphere, it allows for warm moist air to go into the interior, and this warm moist air will condense from clouds, and there we are. We have your precipitation during which season? During summer. Now, here are typical examination questions that you could be asked regarding the influence of these high pressure cells. Identify the season illustrated in sketch A. So sketch A, what do you see? You see the inversion layer being above the escarpment. So this will be summer. Give reason for your answer. We have already given reason. It is the inversion layer above the escarpment. You can see that. Inversion layer above the escarpment. You can see that. Weak descending air, moist onshore winds will reach the interior. So you can see warm, moist air reaching the interior, and then wet conditions over the interior. So those are the reasons why we say this is summer. And then the next question, identify two factors visible in the sketch which influence the climate of South Africa. So you just look at identify two factors from sketch B. Sketch B. This is sketch B. So it's very important that you identify, it's very important that you read these leading questions. Refer to sketch B, refer to sketch A. Make sure that you refer, you read your leading statements. You read your leading statements because they are going to show you what is expected of you. They say, identify two factors visible in the sketch which influence the climate of South Africa. What can you see here? This is number one. You can see that. You can see that there. You can see this are what you can see. Weak descending in sketch B. Identify two factors. You can see there is plateau. You can see height above sea level, ocean currents. You can see all these things. You can see everything here. So the examiner wanted to give you free marks. The examiner wanted to give you free marks. But you'll find that some people not getting it right because some people will not read because this is just free marks. This is just free 2 marks. Explain the role played by descending air in the development of the inversion layer. What role is played by descending air in inversion layer? So that is also air subsides, it compresses and heats up. Subsiding air compresses and heats up, and adiabatic heating due to subsiding air. Now let's look at 1.5.5. In a paragraph of approximately 8 lines, these are the answers, or these are the questions that nobody should ever leave. You should never leave these questions. They say, describe how the position of the inversion layer in sketch A and B influence the amount of rainfall. So just by looking at this, and sketch A is above the escarpment. So there's going to be more moisture coming into the interior, more condensation, and more rainfall. And this one, the inversion layer is below the escarpment, so it's going to limit the amount of warm air, and then which limits the amount of warm and moist air. What's going to happen? The conditions are going to be dry, and with the conditions are dry, there's no condensation because the air is heating up, because the air is subsiding. So in this condition here, this is more where we're going to get your bergwinds. This is where we are going to get your bergwinds in diagram B, bergwinds. The air is subsiding and the air is blowing from the interior to the coast. So because the air is blowing from the interior to the coast, there is going to be limited amount of rainfall. because the air is blowing from dry land. But here, the air is blowing from the ocean and is reaching the interior. So those are the answers that are there for you to give. Now, line thunderstorm, we've already spoken about thunderstorm in so many times, but it is very important that you must be able to describe these winds. You must name these winds is moist. This is warm and moist air. Sometimes the examiner can ask you just to give the characteristics of this air mass. And then this one is cold and dry air. So sometimes you could just be asked to give those characteristics. Now, because of the two air masses that are blowing together, the two air masses blow towards each other. Now, this one is colder and drier, is going to undercut this warm air, and this warm air is going to rise rapidly. And as it rises rapidly, condensation is going to take place, and we're going to have what you see here, line thunderstorm. And the impacts of line thunderstorm are the same impacts of tropical cyclone on the natural environment. They are also the same as the impacts of the mid-latitude cyclone. Why? Because of cumulonimbus clouds. So I'm not going to go there. We know it is destruction of vegetation, soil erosion, soil lose fertility, destruction of ecosystem, destruction of natural habitat. So it's the same impact as those that we did when we were talking about tropical cyclones and mid-latitude cyclones. Now, here are short activity questions here, which you must master. Now, let's look at this line thunderstorm here. Let's look at the line thunderstorm here. According to the extract, in which season do line thunderstorm? Even if the extract is not there, you must know line thunderstorm occur during summer because the warm moist air is able to reach the interior and the cold dry air from the west is going to undercut the warm moist air, forcing it to rise. And now, describe the temperature and moisture content. Describe the temperature and moisture content. This one is cold and dry. This one is moist, is warm and moist. Because it's warm, there's going to be more evaporation. That's why it gets moist. This one is cold. Because it's cold, there's going to be less evaporation. That is why it is going to be dry. So those are the characteristics. So now let's look at this question here. It says, explain why the heaviest rainfall occurs closest to the moisture front, as evident in the source. Why are we going to have heavier rain here and the rain is going to decrease when you move away from here? Is because this part over here is closer. This part over here is closer to the moisture. It's closer to the moisture. So even if you can somebody stay closer to the heater and somebody moves further away from the heater, which of the two people will experience higher temperatures? The one who is closer. And then why are we going to have rainfall closer to moisture front? Because that is where condensation is taking place. That is where there is high level of condensation. That is where we have more moisture. But when you're moving away, then the moisture is also going to decrease. So these are just the common sense questions that one must learn. It's not something that teachers would want to do. It's not part. It's application of question. The teachers are going to teach you the knowledge. They're going to teach you knowledge, but now you will have to learn how to apply the knowledge. You have to learn how to apply the knowledge because application is something that will be asked in different ways, but just have to explain your knowledge. And now here is that question again. The impact on the natural environment. The impact on the natural environment. So we said the impact on the natural environment for tropical cyclone is the same as the impact for tropical cyclone, mid-latitude cyclones, and line thunderstorm. So the impacts are the same. Okay. Now what do we have there? We have your berg winds. you must be able to define what berg winds are. Berg winds are hot, dry winds that blow from the interior to the coast during summer. So what you should know, the impacts of berg winds will also be similar to the impacts of tropical cyclones, similar to the impact of tropical cyclones, mid-latitude, and line thunderstorm. But the difference is the other one is going to destroy vegetation because of strong winds. But with tropical cyclone, there could be rainfall and flooding, but the impact on the natural environment is the same. They both destroy natural habitats. They both uproot plants. All of them uproot plants, cause soil erosion, destroy habitats, disrupt ecosystems. But the other ones, South African berg winds will be through fire that will exist there. It will be through different ways, but the impacts will be the same on the natural environment for both berg winds, mid-latitude cyclones, tropical cyclone, and line thunderstorm. The only difference will be the cause. The only difference will be the cause. But when it comes to the damage on the natural environment, it's going to destroy it in the same way. It's going to cause soil erosion. It's going to destroy natural vegetation. It's going to destroy habitats. It's going to, but with the berg winds, it is because the winds are blowing the soil. But with tropical cyclone, mid-latitude cyclone, and line thunderstorm is because water is washing the soil away. But there is soil erosion on both. The other one, berg winds are also associated with fell fires because the air is hitting adiabatically and there is friction between the surface and the dry winds that results in fell fires. And therefore, they can also destroy vegetation like that. But the destruction is the same, though it is because of different factors. The other one is because of water. The other one is because of wind and fire. Okay, move on. We're done with that. Now we're looking at what we call microclimates. Microclimates simply refer to the climates that affect smaller areas. Microclimate are simply the climate that affects smaller areas. What are we looking at now? We're looking at valley climates. What do we have there? We have what we call katabatic winds. Katabatic winds that occur during the night, the cold air subsiding, and the cold air accumulating at the bottom of the valley. And then when the cold air accumulates at the bottom of the valley, what is going to happen? The temperatures at the bottom of the valley are going to drop below freezing point. And then when the temperatures drop below freezing point, we're going to get what we call frost pocket. And then what is the implication? It means now you cannot grow the crops that will be killed by frost there. You cannot grow the frost sensitive crops at the bottom of the valley because they will be killed. Where are you going to grow them? You grow them just a little bit above them, the frost pocket. And then what are you going to grow here in the frost pocket? You are going to grow the crops that can resist the frost. So what do you have there? You have a process called temperature inversion. You have the process called temperature inversion. What is temperature inversion? Temperature inversion is the increase of temperature with an increase in height. So you can see the temperatures here are lower, but when you go up there, the temperatures are higher. So what is that process called? It's an increase of temperature with height. An increase of temperature with height. So we call it temperature inversion. We call it temperature inversion. And here in this valley, what are we going to get? We're going to have what we call a thermal belt there in the valley, and it shows inversion. It shows temperature inversion. So this one over here, we're going to call it thermal belt. This layer here, we're going to call it thermal belt. But what is it indicating? It is indicating the increase of temperature with an increase in height, which is called temperature inversion. So this takes place during cold, calm winter nights. It takes place during cold, calm winter nights where you're going to experience that. You're going to experience cooling because of terrestrial radiation and cold air accumulating up there and cold air subsiding and more cold air subsiding. When more and more cold air subside, it accumulates at the bottom of the valley and dropping temperatures below freezing point, and we are going to get what we call, we're going to get temperature inversion there. We got temperature inversion, but here at the bottom, what do we call it? We call it frost pocket. But at night, this warm air, which is going to be in contact with this cold surface, is in the early hours of the morning. In the early hours of the morning, when this warm air is in contact with this cooler surface, once the warm air touches the cold surface, condensation takes place. So what will happen there? The warm air touches the cold surface, then we're going to have condensation taking place. Why is condensation going to take place? Because this air is warm and the surface is cooler. When there is contact between warm air and colder surface, then condensation is going to take place. When condensation takes place in the valley, what are we going to get? We are going to get what we call radiation fog. We're going to get radiation fog because condensation is going to take place. But now this radiation fog is more like the clouds, but the clouds are forming to a very low level. It's clouds that are forming at a very low level, and these clouds are going to reduce visibility. And when they reduce visibility, there are high chances of accidents because of there is this clouds at the bottom or on the surface. So that is what happens in the valley. So, and then during the night, I repeat, cold air accumulates on top of the valley because there is terrestrial radiation. The top of the surface becomes cooler, and as it gets cooler, the cold air is going to subside to the bottom of the valley. Then the subsiding cold air accumulates at the bottom of the valley. Now, when the cold air accumulates at the bottom of the valley, the temperatures are going to drop below freezing point. And then when the temperatures drop below freezing point, we are going to get frost pocket. And then what will happen to this warm air that was there is going to move. It's going to move, but it cannot move completely out of the valley because the air above it is also colder. So because the air above it is also colder, it's stuck in the middle of the valley, forming what we call thermal belt there in the valley, forming the thermal belt there. And then because the warm air is going to be found above the cold air, what do you call that process? We call that process temperature inversion. What is temperature inversion? Is the increase of temperature with height. Then what will this process then mean? It means because here we have frost pocket, you cannot grow the frost that can be, you cannot grow the crops that will be killed by frost. Here at the bottom of the valley, you must plant those crops midway above the slope, above the floor, midway above the floor where it is warmer. And then only the crops that are resistant to frost can be grown at the bottom of the valley. So that is how this climatic factors influence the slope utilization. That is how the climatic factors influences the slope utilization. You can utilize slope for certain reason, but not for certain reason. And then we said again, when the cold air when the warm air is in contact with the cold surface, what is going to happen in the middle, in the valley there, is going to be condensation. And then once condensation takes place, we are going to have what we call radiation fog in the early hours of the morning in the valley. Okay, now we have few activities here. Here, let's look at the activity one. It says air at A. Let's look at A. Here is A. Air at A cools because of terrestrial radiation. It says downward movement of air along the valley slopes occurs during downward. It occurs during the night. And then the air movement from A to B results in a anabatic or katabatic. A to B is going to be katabatic. It results in katabatic. Anabatic will be the upslope movement during the day. And then dew point temperature drops to below freezing point at night, at A or at B. At night or at B, it will be at B. At B. Precipitation that forms at B when the dew point temperature drops below zero is frost or radiation. It is frost pocket. It is frost pocket. It is frost that is going to develop there. Radiation fog is going to develop here when there is condensation, but it must not be below freezing point. It is not below freezing point. Below freezing point is frost. Displaced air from the valley result in an inversion layer or thermal belt. This is going to result in thermal belt. Layer C is more developed during the day or during the night. Layer C is more developed during the night, not during the day, because during the day, the entire valley has got warmer air, and then the air is still moving up during the day. The air is moving up. There is no accumulation of cold air there during the night. During the day, sorry. Okay, now let's move on. Here's another activity, still in the valley. It says represent an anabatic wind. Which one represents an anabatic wind? Which is B. This is your anabatic wind. The up slope movement, or when the air moves upslope like that, it is an anabatic wind. Cold air forces the warm air to rise, which forms an inversion layer. The inversion layer is going to be formed here when this cold air that comes here forces the warm air to rise, which is going to be at A. Occurs during the day due to insolation. This is what occurs, which is B. Frost forms on the valley floor when the temperature drops below freezing point, which is at A. So these questions are so similar. So when it comes to valley climates, I expect everybody to get 100% from the questions. Now let's look at the urban climates. Why are cities? So urban heat island. What is urban heat island? You must be able to define the concept of urban heat island. So urban heat island is the warm urban area surrounded by the cooler suburbs. Warm urban area surrounded by the cooler suburbs. So this is your warm urban area and it's surrounded by the cooler suburbs. Now the question is, why is the urban area warmer? Why is it the urban area warmer? You can see the temperatures here are going around 60 degrees. And then here temperatures, the max there will be going up to, it's 20, here is about 42 temperatures, but here it is about 28 or plus. So why are cities warmer? Because of the artificial surfaces that are absorbing heat. It is because of the high buildings that provide more absorption area. It's because of industrial activities that are creating heat. It is because of many vehicles that are also the air creating a lot of heat. And now when you're looking at this one in rural areas, you can see we have natural surfaces and we have low building density. We don't have a lot of buildings here. We don't have a lot of buildings in the urban area, and therefore the heat is escaping easy, and we have vegetation that is not creating a lot of heat, and then natural surfaces don't create a lot or absorb a lot of heat. So what we're looking at here, we're looking at the isotherms. What we are looking here, we're looking at the isotherms. What are isotherms? Those are the lines that join places with the same temperature. So if we are looking at this isotherm here and you follow it right around, it shows that the temperatures here around here are around 30 degrees. But when you go in the center here, the temperatures here are around 36 degrees. Why? Now you can start looking at the artificial surfaces. You can think that these are tall buildings that are absorbing more heat. There will be also more activities. There will be more vehicles. So this is the reason why urban areas will be warmer than rural areas. And then we have what we call pollution dome. So it is easy for people to confuse pollution dome and urban heat island. These are two different things. Pollution dome is the polluted air in the city. Polluted air in the city. You can see there's pollution dome here, polluted air in the city, but heat island is an urban area that is warmer than its surrounding. An urban area that is warmer than its surrounding, but pollution dome is a parcel of polluted air in or around the city. So you must know the difference between the two. So we have some activity here regarding to pollution dome. We have pollution dome during the night and pollution dome during the day. So pollution dome during the day is higher because the temperatures are higher during the day and therefore the air is rising. But during the night, the temperatures are lower. So the temperature, a pollution dome is more concentration. There is high concentration. There is high concentration of pollution dome, but here the concentration is lower because the air is rising and pollution is spread. Now, let's say they say A and B, you must choose the correct answer between A and B. Represent a pollution dome at night. This will represent the pollution a dome at night because the air at night is colder and the air is subsiding. And then pollutants are dispersed. Here it is during the day. So because the pollution dome is higher, the pollutants will be dispersed in the atmosphere. Denser concentration of pollutants over the urban area. Denser concentration of pollutants. So the pollutants will be denser here because they are concentrated over a smaller area. Now, the figure shows the difference in temperature between the city and the surrounding rural area of a South African city. And they say, draw a label diagram showing the structure of the urban heat island. So this is the structure showing the urban heat island during the day. So what you must show, you must just show that the urban heat island must look like this, but during the night, it must be a little domey and come closer to the surface. Okay, now let's look at geomorphology. Let's start right away with drainage basin. Let's start with the question first with drainage basin. The question says, match the concept below with the letters in the diagram. Write only the letter A to H next to the question number 2.1.1.1 up to 2.1.8 in the answer book. Now, the first question is, where is the source of the river? So the source of the river will be at B. This is the source of the river. That is where the river originates. And then water table. So this line over here is indicating the top surface of groundwater. So this is what we call water table. So water table, this is what is indicated as water table. And then water table will be indicated by the letter G. This letter G over here is indicating water table. And an interflow. So you must know what is water table. Water Let's start first with source. Source of the river is where the river originates. Water table is the top surface of groundwater, which means here we have water under the ground. What do you call the water under the ground? We call it groundwater. And then what is this upper limit? What is this upper limit of this water under the ground? We call it water table. Then we have an interfluve. An interfluve. Where is an interfluve? An interfluve is at A. So what is an interfluve? An interfluve is an area that separates the streams of the same drainage basin. So you have different streams. You have different streams there, and you have the main stream there. So these streams that you see here, they are separated. They are separated by these high-lying areas between them. It is called interfluve. So what is an interfluve? Is a high-lying area that separates the streams within the same drainage basin. Then, what do we have here? We have this drainage basin, this side, and we have another drainage basin, this side, which is indicated by this dotted lines there. So, this a drainage basin and another drainage basin. Now, this is a drainage basin. So you need to be able to define what a drainage basin is. The total area drained by the river system. Drainage basin is the total area drained by the river system. We call it a drainage basin, which means this entire area is a drainage basin. This entire area is a drainage basin because it has got a river system. Now we spoke of river system. It means you must also have another concept to define there, which is a river system. What is a river system? River system is equals to the mainstream. This is your mainstream. This is your mainstream. And all these rivers that are flowing into it are called tributaries. So the mainstream and all its tributary equals to the river system. So the whole area drained by the river system is called a drainage basin. So where is drainage basin? This is C. So it is indicating the boundary of a drainage basin. Then the river mouth. Where is the river mouth? The river mouth is at E, where the river flows into the sea. Where the river flows into the sea, we call that point a river mouth. Then we have a watershed. There is your watershed. There is your watershed there. We have drainage basin this side, another drainage basin this side. They are separated by a watershed. Don't confuse watershed and interfluve. Interfluve separates the streams within the same drainage basin, but the watershed separates two or more drainage basins. Watershed separates two or more drainage basin, but interfluve separates streams within the same drainage basin. Then we have a confluence. We have a confluence. What is a confluence? What is a confluence? Confluence is at number D. Where is our D? This is our D. So a confluence is where two streams join. It can be a stream, it can be a mainstream and a tributary, or a tributary joining the mainstream. That point is called confluence. Or it can be where two tributaries are joining each other. So long as the streams are joining, that point is called a confluence. And what do we see here? We call infiltration. The process of infiltration is the absorption of water by the surface. Hope we're fine with drainage basin. Then we have stream patterns. We've got different patterns that we have. We have studied different patterns. So we have dendritic pattern. What you should know, you must be able to describe it. You must be able to tell what is the underlying rock. Now let's look at the dendritic pattern. We have trellis pattern, we have radial pattern, rectangular pattern, centripetal, deranged, and parallel. So we have different types of drainage patterns. Let's look at few activities on drainage patterns. Let me just quickly look at the characteristics of drainage patterns. Okay. Sometimes you get an examination, they want you to give characteristics of those patterns. Now, dendritic pattern, what are the descriptions or what are the characteristics there? It looks like the branches of a tree. It does not look like a tree. It does not look like a tree, but it looks like the branches of a tree, because different trees will have different shapes, but the branches inside a tree will look more the same. And the tributaries join the mainstream at an acute angle. There's an acute angle that we are looking at here. There's an acute angle that we are looking at here. So that is the characteristics. And then where do we find dendritic patterns? Where the rocks have got uniform resistance to erosion. They have uniform or similar hardness. They have uniform or similar hardness. So that is your dendritic pattern. Then what do you have next? We have trellis pattern or trellised pattern, depends on how you want to pronounce it. Now, this is your mainstream. This is your other mainstream. So what do you see there? The mainstream are flowing parallel to each other. Mainstream are flowing parallel to each other. You can see this is the mainstream there, another one there. What you can do, what you can see as well is that instead of acute angles, now the tributaries join the mainstream at a right angle. Tributaries join the mainstream at the right angle. And you can also see the tributaries are shorter. And then where do you find the streams? You find the streams in where there is alternating hard rock, gently sloping alternating layers of hard and soft rock. So here we have soft rock. That's why we have the streams. And here the surface is very strong or very hard and resistant. So there is no streams here. So there is soft rock where you have streams, hard rock, no streams. Soft rocks where you have streams, hard rock. So it's found where alternating soft rocks and hard rocks are found. Then what do we have? We have radial. Radial simply meaning to radiate, which means now water is falling into this high-lying area and the streams radiate. They flow away from the high point, and then it is going to be usually found where you might have a mesa or a butte or any high-lying area that can allow for that. And then we have rectangular pattern. As the name says, rectangular, the tributaries join at the right angle. So with a rectangular pattern together with the trellis pattern, what is similar with them? The similarity between rectangular pattern and trellis pattern is that tributaries join the mainstream at the right angle. But now we're looking at the characteristics of the rectangular pattern. The mainstreams also have a 90 degrees bend. The 90 degrees bend. So we've got two 90 degrees. The mainstreams bend at 90 degrees, and the tributaries also join the mainstream at 90 degrees. Then where do we find them? We find the stream patterns where we have jointed igneous rocks, Then we have what you call centripetal. Centripetal, it is the opposite to centrifugal. So this one, sometimes the radial is sometimes called centrifugal, meaning that the streams are radiating away. But the streams are flowing towards a low-lying area where the land has since subsided. And then what do we have here? We have the ranged pattern. The ranged pattern is usually, like the name says, the range doesn't have a definite pattern. The streams flow in and out of lakes. It is usually found where there has been a glaciation, or which is the moving ice or flowing ice. So that is where it is usually found. And then we have parallel pattern, and the parallel pattern is usually found where the gradient is very steep hill. Streams flow parallel to each other because of the steeper gradient. And then it is common along a ridge or a hill. Just like this other one, the trellis pattern, it is also common where you are going to find incline strata. Sometimes they say the underlying rock where you have incline strata. Let's move on with our patterns. Now, here are the activities on patterns. Identify drainage pattern A. This one, it looks like a radial pattern. You see the streams are radiating away. Determine the stream order of X in drainage pattern A. So what are you looking at here? You say this is stream order 1 and stream order 1. They are going to make stream order 2. So the pattern there is stream order. The stream order there is stream order 2. Give reasons for the direction in which the streams flow in drainage pattern. So the streams are flowing from the higher lying area. Give the reason. The streams are simply flowing from the higher lying area. How does the joining of the tributaries to the mainstream differ in drainage pattern A and B? You can see the joining here is acute. We have an acute angle, but here you can see there is 90 degrees angle. State two conditions associated with the underlying rock that contribute to the formation of trellis pattern. Two underlying. So number one, it is soft and hard rock, alternating soft and hard rock. Alternating soft and hard rock, that is the first one. And the second one, it is where you have inclined strata. Inclined strata, that's number two. And it says, why are human activities limited in areas where drainage patterns A and B are found? Why are they limited? Human activities, number one, they are found where the areas are steeper. They are found where the areas are steeper, number one. Number two, it is not easy to build in those areas. So it is steeper area with difficulty to build. So that is why they are not easy they are easily habitable. Land is steeper, it's prone to soil erosion, the soil is infertile, there's a risk of mass movement, high cost of developing. It's not easy to develop there. So there are a number of reasons that we can give why this is not easily habitable. Now, let's look at two other drainage patterns there. Identify drainage pattern in sketch A and B. So you can see the mainstreams are bending there at 90 degrees, which means this one will be rectangular, and this one looks like the one that we're looking at, which is the same one as this one, the same one as the first one that we're looking at here, which is the dendritic pattern. State the underlying rock structure and rock type on which the drainage pattern A developed. So the underlying rock here, it is rock, it is a igneous rock that is jointed. It is igneous rock that is jointed. Jointed igneous rock or horizontal layered. Let's continue. Identify drainage pattern in sketch A and B. So sketch A, we said the drainage pattern there is rectangular pattern, and sketch B is dendritic. And then state the underlying rock structure and rock type. Underlying rock structure and rock type in drainage pattern A developed. We said number one, the rock structure is jointed, faults, or horizontal layered. Okay, then we have let's go back to okay. Explain how the underlying rock structure influenced the drainage pattern at A. What's happening here? Explain how the underlying rock structure influenced the drainage pattern at A. So what is happening there? The streams are following the joints. The streams are simply following the joints. 2.3.4 drainage density in B is low or high. Drainage density in B is higher than the drainage density in A. Explain the relationship between the stream order and drainage density. The relationship between the stream order and drainage density is that when the stream density is higher, the stream order will always be higher as well. And when the drainage density is lower, the stream order will also be lower. Explain how the slope or gradient and permeability of underlying rock influence the drainage density. So let's come to this page now. What are we looking at here? We're looking at drainage density. So as we are looking at drainage density, we must be able to define the concept drainage density. So drainage density is the total number of streams divided by the total area of the drainage basin. Total number of streams of a drainage basin divided by the total area of the drainage basin. Now, drainage density is influenced by two processes, infiltration and surface runoff. And there are also factors that influence drainage density, which is gradient, porosity and permeability, type of precipitation, soil moisture, vegetation, and type of soil. Now, this is the game that I want us to play when it comes to drainage density. We said drainage density is influenced by infiltration and surface runoff. So that infiltration will result in low drainage density, and surface runoff is going to result in high drainage density. Because when there is more infiltration, there's going to be less water on the surface. But when there is more surface runoff, there's going to be more water on the surface. Excuse me. Now, let's look at the drainage density now. Excuse me. Let's look at drainage density at A. Let's look at the drainage density at A. Sorry, not A. That's not A. Drainage density at A. What's happening here? Yeah. Let's look at the drainage density at A. How is the drainage density at A compared to the drainage density at B? Now, the drainage density at A, we can say drainage density at A is higher. Now, here are the factors that are influencing drainage density. It's gradient, porosity and permeability, type of infiltration, type of precipitation, soil moisture, vegetation, and type of soil. Now, here is a simple question. Explain how gradient influence density at B. If you get that question, say explain how gradient influence density at A or at B. Let's start with B. If you are to answer that question, you say at B, the gradient is gentle. And because of the gentle gradient at B, there is more infiltration and there is less surface runoff. That is why the density is low. And now let's look at A. How did the gradient influence density at A? Then you say at A, the gradient is steeper, and therefore there is more surface runoff and less infiltration. That is why we have high density. Then that is how you approach your question. Sometimes they say you explain how did vegetation influence density at A. Then you say at A, there is less vegetation. Because of less vegetation, there is more surface runoff and there is less infiltration. That is why the density at A is higher. They say, how did vegetation influence density at B? At B, there is more vegetation. That is why at B, there is more infiltration and less surface runoff. That is why the density is lower. Then we have another factor like porosity and permeability. And porosity and permeability is the same as the type of soil. It's the same as the type of soil because porosity will determine whether soil is able to allow infiltration or not. Then what are you saying? Saying at A there is low porosity. What do you mean by low porosity? There is fewer pore spaces. You're saying at A, there are fewer pore spaces. Because of fewer pore spaces at A, there is more surface runoff and there is less infiltration. And that is why we have higher density. But the opposite is taking place at B. At B, the area is high or has high porosity. Because of high porosity, there is more infiltration at B. And because of more infiltration at B, there is less surface runoff. That is why at B, there is lower density. Remember we said density is influenced by two processes, infiltration and runoff. And that infiltration and runoff is also influenced by these factors. Then we say type of precipitation. Now it means at A, there was heavy rainfall. There was heavy rainfall, which means that it rained quickly. There was not enough time for water to infiltrate. That is why we have high density. But at B, the rainfall was slow, soaking, more infiltration, and therefore less density. Because there is more infiltration and less surface runoff. And then soil moisture. What does it mean, soil moisture? It means at A, the soil is saturated. At A, the soil is saturated. And because the soil is saturated, what do we mean saturated? The soil is full of moisture. And therefore, there's going to be less infiltration, but there's going to be more surface runoff. That is why A has higher density than at B. And it means at B, the soil is dry. Because of the dry soil, there is going to be more infiltration. And because of more infiltration, there's going to be less surface runoff and lesser drainage density. And we have already spoken about vegetation, and type of soil is the same as porosity and permeability. It means the soil at B is more permeable. Now, permeable means that the soil is allowing for water to infiltrate and therefore resulting in low density. That is why we have fewer streams. But at A, it means the soil is less permeable and therefore more surface runoff and less infiltration. Now, let's continue with stream orders. So stream order is something that we have done. You can also refer to the video that we have shared earlier this year. So what do we have there? We have stream order 1 and stream order 1 making stream order 2. But when you add stream order 1 and stream order 2, we remain at 2. because the stream orders of a different order, when you add them, they remain at the highest order. They don't change. But when you add 2 and 2, they will give us 3. When you add 2 and 2, stream order moves to 3. But when you add 1 and 1 is going to give you 2. 2 and 2 will give you 3. 3 and 1 remains at 3. 3 and 2 remains at 3. But 3 and 3 moves to 4. So that is how so what you should also know is that when you see the drainage, the order being higher, it is also showing that the density is higher. But here, so when you're looking at the drainage density at this point, the drainage density at this point is going to be lower than the drainage density at this point. Because here, what do we have there? We have third order streams, but here it ends up at second order. So sometimes the examiners ask you interesting questions when it comes to stream order. They can ask you, how will a prolonged rain influence the stream order? How will the prolonged rains influence the stream order? So if there is rain that takes place for longer periods, or it is raining for longer period, it means more streams are going to develop. So which means the stream order will also increase. And then they can also ask you, how will drought influence the stream order? So what will happen if the drought takes place? It means the first order streams will be drying out. And if the first order streams are drying out, it means now we'll be left with the second order streams and the third order streams. Now the second order stream becomes stream order number 1, and then stream order number 3 becomes stream order number 2. So what is happening to the drainage density? The drainage density is becoming lower. And then as the drainage density becomes lower, how is that influencing the stream order? The stream order is also becoming lower. But if we increase rainfall, we're going to increase the number of streams. And then we're going to increase the number of stream orders. The stream order is increasing. So it goes now from 4 to 5, 5 to 6, because there is more surface runoff and there are more streams. But if there is drought, now they reduce. The stream order 1s become the stream order 2s, and the 2s become 3. So that is an application type of question that you might expect to get. Or that could be, it's just, you must apply your mind when you're reading these questions. Okay, now what are we looking at here? We're looking at river discharge. River discharge. What is a river discharge? River discharge refers to the volume of water in a river as it passes a specific point in time. A river discharge is a volume of water in a river as it passes a specific point in time. And then this river discharge can be high at a particular point in time, or it can be low. And then what we see again is that when river is flowing, river can flow in 2 ways. River can flow in a gentle surface or in an uneven surface. When a river flow in an even surface, in a lower course, it's going to flow in a characteristics called laminar flow, where water flows as parallel sheets, as you can see in the diagram here, and riverbed is even or smooth, and there is less erosion, and it occurs mainly in the lower course of the river. So at this stage, you can say the river is gradient. It is graded. And then here, in turbulent flow, water flows in turbulent, riverbed is uneven. What do we mean it's uneven? There are waterfalls, there are rapids there is more erosion, and this process is more likely to take place in the upper course. But here, there is more balance between erosion and deposition. Here, we have a dominant erosion as a process. Okay, now we are looking at the longitudinal profile of the river. What is a longitudinal profile of the river? Is the view of the river from where it starts, which is the source, to where it ends, which is the mouth. Now, when you're looking at the river again, long profile of the river, it has the upper course. So this will be the upper course, and this is the middle course, and this is the lower course. So the river in its upper course has got a steeper gradient, and the water is flowing fast. There is dominant of downward erosion or vertical erosion, and the area has got waterfalls, got rapids, interlogging spats, and you can see the volume of water is very little. Then in the middle course, you can see the volume of water is increasing because more tributaries are joining the river. And then what is happening? The gradient is gradual. The river flows slower because it's no longer as steep in the upper course. It's getting gradual. And there is lateral erosion. Lateral erosion means sideways erosion. Means now the river bed, not the river bed, the river is becoming wider. The river valley is becoming wider. The river valley is becoming wider. And then we have the lower course. What is happening in the lower course? What is happening in the lower course? The river is almost flat. The river is almost flat. And what is happening there? You can see it is almost flat. The river is flowing very slow. There is dominance of deposition. Then we have different features that are occurring there: oxbow lakes, deltas, meanders, marshes and flays, braided streams, sandbanks. So these are what you can expect to find in the lower course of the river. Now let's quickly look at these questions here. They say various options are provided as possible answers. No. The question is, let's look at the first question. The profile from source to the mouth shows the dash of the river. From the source to the mouth, what does it represent? It shows the length of the river. And then what do we have there? The stages. Now these stages are scrambled up. The stages are scrambled up. What you must do, you must choose the correct order. It says here, the stages X, Y, and Z are stages X, Y, and Z. So it must be upper course, it must be middle course, and it must be lower course. So it will be upper course, middle course, and lower course. So the correct answer there will be C. Describe the river valley at X. So we're looking at the river valley at X. Is it wide and shallow? Is it wide and deep? So the correct answer there, it is narrow and deep. It is narrow and deep. And then at Z, the river has a laminar flow due to a river bed. How is the river bed at Z? How is the river bed at Z? Is it rough and uneven? Is it steep and even? Is it gently sloping and even? So the correct answer there will be number C. Slope T on the meander is the what slope? Slope T. So you can see slope T here is deeper, showing that there is more erosion at T. There is more erosion at T because water is moving faster at T. So slope T is going to be called an undercut slope, and which means the slope S. Slope S will be called a slip off. That is where it is shallow here. At S, this is a slip off. And then this one over here is the undercut. And then which means this one here is going to be gentle, and this one over here will be convex as well. Slope S on the meander is associated with A. Slope S. Is it associated with the steep gradient and deposition, gentle gradient and erosion, concave slope with erosion, convex slope with deposition? So here it will be convex slope with deposition. Okay, let's move on to the next question now. So this is a map showing the river in the upper course. So this is what we call rapids. This is what we call rapids, and this is what a waterfall is. So these are the features that you're going to find in the upper course of the river, and then this is a map showing the upper course of the river. You can see the contour lines that are very close to each other, indicating that the gradient is very steep. And this is the middle course of the river. You can see now with the contour lines being far from each other, you can see there's a lot of dams there, indicating that the gradient is gentle there. And then what do you have there? This is the lower course. Then you see the braided streams there. So don't confuse braided streams to your deltas. Your braided streams, the rivers is going to break. Now, this is the lower course I was saying. You must be careful when you're looking at the braided stream, as compared to deltas. So this is a river in its lower course. What is the evidence that is a lower course? Number one, there are marshes and flays that you can see there. Number two, you can see the well-developed meanders there. You can see braided streams there. You can see wider floodplain. You can see meandering there. So this is the features that you find in the lower course of the river. There is what you call your oxbow lakes there. You have your meanders there, and then you have abundant channels of the river there. And then this is what you call a delta. So a river has now broken into distributaries. The river has broken into distributaries as it flows into the sea. The river has broken into distributaries as it flows into the sea. So this is your features that you find in the lower course of the river. Now, what we have here, we have river grading. We have two grade, we have an ungraded river. This is where you are going to have turbulent flow. Why do you say this river is ungraded? Because there are nick points along the course. And then there is a dominant erosion. Erosion is dominant here. There is dominant erosion because there are still obstacles along the course of this river. But this one is a graded profile, which means there is a balance between erosion and deposition. So in profile, this profile, graded profile, we say this is in equilibrium. There is no dominant process. But here, because there are obstacles or there are nick points, and then you must be able to define what's a nick point. So here is a gradient of the river, and at this point, it changes suddenly. It changes suddenly. Here it is, it changes suddenly. Here it is, it changes suddenly. So where there is a sudden change in the gradient of the river, we call that point a nick point. Now, we're looking at a cross profile through a meander. It is the same diagram that we looked at in the previous questions when we were looking at the a meander. So this is what we have. We have a river flowing on the outside and it's flowing faster. And because it's flowing faster, there's going to be more erosion. And on the inside, the river is flowing slower and there's going to be more deposition. And then if you are to draw a cross section of a meander, you must know it is either a Nike that is straightforward or it is a Nike that is in reverse. So where you have your undercut, it will be deeper, and where you have slip off, it will be shallow. So you just draw a Nike like that, depending on which side. So here you're going to have the river being deeper because it's undercut this side, and this side it's shallow. So if the river, if it was bending to the other direction, then your Nike will face a different direction. You just draw a Nike like that. It's a Nike tick, just tick a Nike tick. That is your cross profile through a meander. It can be a Nike in the right direction, or it can be a Nike in the opposite direction. So why is the undercut deeper? Because the water is flowing faster and there's going to be more erosion. Why is the slip off shallow? Because the water is flowing slower and there's going to be more deposition. Okay, let's continue. Now, let's quickly go through the river capture or stream piracy. What is stream piracy? Is when an energetic stream diverts headwaters of a less energetic stream. When energetic stream diverts headwaters of a less energetic stream. So this is simply an animation of is a simple animation of a river capture. So what do we have? We have two streams, or we have two drainage basins separated by the watershed. So for a river capture to take place, we need two processes. The first process is called headward erosion. What is headward erosion? Is when you see this river is flowing in this direction, but erosion is taking place in the opposite. We call that process headward erosion. When the river erodes towards the source, the water is coming from this way, but it's eroding in the opposite direction. That's what headward erosion. But now, these two streams are separated by the watershed. So what must happen? Number one, this watershed must be lowered and be removed or shifted. So that process of lowering and shifting of the watershed is called abstraction. So the processes that are needed for river capture to take place is headward erosion and what we call the shifting and the lowering of the watershed, which is the abstraction. It is the abstraction of the watershed. Now, as you can see, it means now this river is flowing on a steeper gradient, and this one, which is river B, is flowing on a gentle gradient. So because river A is on a steeper gradient, it's going to do what we call headward erosion, lowering and removing the watershed through the process of headward erosion. And then once that takes place, the two rivers are going to join. And then when the two rivers join, river will now be flowing to their lowest point, which means now river A is on a steeper gradient, but at a lower lying area. This one is on a gentle gradient, but on a higher lying area. So then, at the point where they join, what's going to happen? This water is going to flow towards the lowest point. This water is going to follow a steep gradient towards the lowest point. And then what is happening now? This is what we call river capture or stream piracy. And we must be able to label the features of a stream piracy. Number one, this is a point where these streams joined. So what we call it, elbow of capture. And then this river that has taken water of another stream is called a captor stream. And then this stream that has followed the stream that is flowing on a lower lying area is called captured stream. And this stream that no longer receives water because the water has been diverted is called a misfit stream. And then this area where river used to flow, but there is no longer water flowing there. This area is dry. It has got gravel. This area is now called the wind gap. So these are the features of the stream piracy. Now, what will be the disadvantage for the people that are living downstream where the river has been, at the downstream where the river has been diverted or where the river has been changed its direction? So there's going to be water shortage. For farming, there's going to be less fishing, there's less recreation, and there's less industrial activities because of the shortage of water. But now, what is going to happen where the river has gained more water? The soil will be fertile, there's going to be more water for farming, the economy will grow, there are high chances of flooding and high chances of erosion. So, this is what might happen to the people that are living here. But sometimes the examiners don't want to know about the impacts to the people living downstream or to the people living downstream at the misfit or to the captor stream. Sometimes the examiner will ask you to give a impacts of this process on the rivers themselves. What is the impact of river capture? What is the physical impact? So it means now what will happen to the river itself? So it can be what will happen to the captor stream or what will happen to the misfit stream. So you must be careful. Sometimes it say you can be asked to answer the question, what will happen to the people around? But sometimes they ask you what will happen to the rivers themselves. Now, what is going to happen to this river? The river is going to have more water. The river will rejuvenate because it is going to regain more energy. The river can cause a lot of flooding. The river is going to have more vertical erosion. The deposition will decrease because now the river has more energy for erosion. Then what will happen to the site? There is going to be less energy. So if there is less energy, there's going to be more deposition. With more deposition, there's going to be the river is also going to be smaller than the valley that is flowing through. The river becomes smaller than the valley that is flowing through. So those will be the challenges that this is going to experience. So you must be able to answer, to respond to what will happen to the people that are living downstream or what will happen to the streams themselves. The stream that has captured more water is going to have more water. The volume of water increases. The speed of water increases. Vertical erosion increases. There is higher volume of water, like I said. But when you look at the stream that has lost or that has been captured, there's going to be less volume of water. Because of less volume of water, less erosion, more deposition. Okay, that's another example of river capture. Now, here is the activities that you need to do. Define the concept river capture. Is when an energetic stream diverts headwaters of less energetic stream. State one condition needed for river capture to take place. Number one river must have more water than the other. One river must be flowing on a steeper gradient. Number three, one river must flow on a lower lying area and the other one on a higher lying area. So those are the factors that are going to result in the river capture. Now, the question says, draw a sketch to illustrate the area after river capture has taken place. You can see here, river capture has not taken place. So we still have the watershed abstraction process has not taken place, though headward erosion is still taking place, but it has not yet cut through the watershed. Now, let's see what has happened. Now, in the next step, what has happened is that headward erosion continued to take place. After headward erosion took place, now the stream that is on a lower lying area, but on a steeper gradient, managed to capture the stream that was flowing on a higher lying area, but on a gentle gradient. So this is what has happened. And now must also be able to answer these questions. Will river Y or river Z experience rejuvenation? What is rejuvenation? It is when the river renews its erosive ability. When the river renews its erosive ability, or when a river begins to erode vertically again. We call that process river rejuvenation. Now, the same 2.4, 2.5 and 4, will river Y or river Z experience rejuvenation? So this is river Y. It is going to experience rejuvenation because it's going to gain more water. But river Z cannot rejuvenate because it has lost water. So it has lost energy. The question, give reasons for your answer. We have already given that answer. And explain the impact of the change of the capture stream. So we have already explained what will happen after a river takes water meandering. What is going to happen to the meander? The meanders are going to become deeper. So once the rivers becomes deeper, we say the rivers are in the trench, or the rivers, or the meanders are incised or are entrenched. A trench, a trench is a hole. So this is a meander in the hole. So the evidence of river rejuvenation is incised meander or entrenched meander. And then you can see now we have terraces, meaning that the river valley was at this point, then it came to that point, then it moved to that point. So it is terraces. It is terraces that indicate that rejuvenation has been taking place over a period of time. We can also have what we call a valley within the valley. So you have your valley there, and the rejuvenation takes place, which means now the river cuts deeper in the existing valley. So that process is called valley. That feature is called valley within the valley. So we have different features that indicate river rejuvenation. And last question that I want us to look at is the river of drainage basin management. This is a common question. I have seen this question in all examination questions from 2021, 2022, 2023, 2024. There was always river management there, or drainage basin management. So this is a question that usually comes. This is a question that usually comes in a case study or in an infographic. So what is important with this thing is you must know the strategies. Suggest 3 sustainable strategies that can be used. So most of the answers that are common with this will be the strategies. What is key here? Okay, you must know what does the abbreviation DWA stands for. DWA stands for Department of Water Affairs. But usually this, I say, comes in a form of a extract. You'll have an extract that you have to read. That extract could be that extract can be what you call infographic, or it can be just an extract, one extract that you read from. So most of the questions there will be based on the source that you have. But what is important is strategies. Strategies. So this sustainable strategies to implement to maintain the quality of water. So I want you to understand that when you speak of strategies, the first strategy that you should give if you are answering any question, it must be education and awareness. It does not matter what the question is. If it's a sustainable strategy to reduce urban heat island, you must know its education and awareness. If it's a strategy to keep the rivers clean, you must know its education and awareness. If it's a strategy to reduce the impacts of tropical cyclone, it is education and awareness. If it is a strategy to reduce the impacts of mid-latitude cyclone, is education and awareness. So education and awareness is the first strategy that you give when you are given any problem, because you cannot solve any problem when you don't know anything about it. So first, you must know about the problem. You must be made aware of the problem. And then that is the only time you'll be able to solve the problem. You can't solve the problem that you don't know. So education and awareness is the first strategy to solve all kind of problems that you might face. So now let's look at what strategies you can use to solve the problems. I said I'm not going to look into many questions here because the extract that you're going to get for the final paper is going to be different from any other extract. It's going to be different from any other extract. All you need to do, you need to read through the extract, you need to understand the extract. But when it comes to the strategies to solve any problems, I want to emphasize that one, that education and awareness is key to solving any other strategy that you can get. So depending on other strategies, one of the strategies to protect the rivers is to do buffering, whereby you build boundaries to stop people from accessing the river. You can also make legislation. One of the things that you can do in order to solve problems is you can legislate. You can legislate. You can make laws. You can make rules that tell people how to behave. So rules and legislation. And then in order to preserve water, we can also conserve wetlands. You know what wetlands will do? Wetlands are going to clean a river. They serve as a sponge. They absorb the impurities there and allow water to flow, and the water that is being cleaned. So when it comes to these strategies, please, the strategies are very practical. They are very applicable, and then you need to think thoroughly about them. And then drainage, basin, or river management. River management. I expect every person to get 15 marks out of 15 marks. Why? Because the questions there are application questions, and they are going to vary from question paper to question paper. But most of the question papers that I have seen, they had drainage, basin, or river management. And I want to say at this point in time, I thank you for paying attention, and I'm going to add